All right. So we just went over these two warm-up problems, reviewing simplifying rational expression and solving a linear equation. And now we're looking at these examples down here. So we have to solve a rational equation. What we're going to do is we're going to get a common denominator on both sides, and then we'll be able to eliminate that denominator. So what are some of the terms that we have in our denominator so far? What do you guys see?
X and 2.
Lane sees x and 2. Anybody else see x and 2 in the denominator? Yeah. So what we're going to need is we're going to need every denominator to be 2x. So the first one, so I'm going to write that here as the least common multiple. That means that's the common denominator, 2x. That's what we want. So the first denominator is missing what part of 2x? Yeah, the 2. Yeah, good. So it has the x, it's missing the 2. So I'm going to multiply the first fraction by 2 over 2. The second fraction is missing what? X. Good. So it's going to get x over x. And then the third fraction is missing what? The 2. All right, so now all my denominators are 2x. Good morning. These two can combine into one fraction because they have a common denominator. 2 times 4 is 8. And then plus 5x. Negative 11 times 2. And then 2x. All right, so what we're going to do now is we are going to multiply both sides of the equation by the denominator. And what that will do is it will eliminate the denominator, making this a much easier problem. Remember that you can multiply both sides of an equation by something because that will keep it balanced. So what I'm going to do is multiply both sides by 2x. Just by 2x, not 2x over 2x this time. You see how I'm keeping it balanced because I'm doing it on both sides. That will cancel out my denominators, giving me a much easier problem to solve. Yes.
What does LCM mean?
It's least common multiple. So the least common multiple of 2 and x is 2x. It's basically what we use for our common denominator. All right, so now we need to solve the linear equation, okay? We have to get x by itself, so what would be our first step? Minus 8, good. All right, and then how do we undo the multiplication in 5 times x? Divide. All right, now when we're solving these rational equations, let me freeze this for a second. When we're solving rational equations, we have to check and see if your answer makes the denominator 0. You are never allowed to divide by 0, so your denominator can't be 0. So for example, in this problem, if we got x equals 0, normally 0 is fine. It's a number like any other number. But then plugging that back in here for x, we would have a denominator of 0, not allowed. Okay? In this case, our denominator is negative 6, and when I put it back here, it just makes a denominator of negative 6. That's not a problem. Okay? So we're just checking for extraneous solutions, and those would be the ones that make your denominator 0. So I'm going to unfreeze and I'm going to write some of that on the paper. Okay, so now that I've checked, I can give myself a check mark, okay? Yes. 1 sec. Go ahead. In the step with the green? Okay. So what I did first was I got a common denominator, and then I multiplied both sides of the equation by that same denominator. I was allowed to do that because I did it on both sides. And then when I multiplied by the denominator, it's multiplied by and divided by, and those canceled out. Thank you. Thing two. And unfreeze. So I want you to go back now and fill in the words for what we did. So in the first step, what did we do? And then the second step, what did we do? And then finally, what did we do? I'm going to say make a common denominator. Okay. So once we have a common denominator on both sides, then we eliminated the denominators by multiplying both sides. So we got rid of them. All right, once we got rid of those denominators, we had a much easier problem to work with. And we were left with an equation to solve. Now, this equation is linear. You might, as problems get harder, end up with quadratic equations to solve. And we'll talk about that too. But we'll solve the remaining equation. Okay? And what did we check for at the end? We checked to see if your x would make the denominator equal what? 0. Yeah, so we can't have a denominator of 0. So the answers that we're checking are called extraneous solutions. Extraneous solutions means you did all the steps right, but you still have an answer that doesn't work. So check for extraneous solutions. You can't have a denominator equal to 0. And we're going to do another problem together, and then we'll have 3 problems on the back to work on. Okay, there's only one thing in the denominator. What is it? X, right? So, first one already has x. Second one, it needs an x. So I'm going to multiply it by x over x. And the last one, it needs an x. So multiply by x over x. Yes. So yes, there are different ways of keeping things even. Sometimes we'll multiply both sides by the same thing, and we multiply everything by that thing. Sometimes when we're multiplying a fraction, we just multiply the numerator and denominator by the same thing, and that will also keep that even. All right, so in this case now, we have a common denominator of x. And then let's see what we have on our numerator. I've got 3 plus, what's x times x? Thank you. And then 4x. Okay. I'm going to do the step that I did right here. So I'm going to multiply both sides by what? By x. Good. Because I want to eliminate my denominator. So that's what I multiply by. Yes. It had an equal sign right here. So 4x is here. I didn't move it. Okay. So when I multiply both sides by x, it cancels out your denominator. And so now I have an equation, 3 plus x squared equals 4x. Is this equation linear, quadratic, or exponential? It's quadratic. Good. Because the exponent is a 2. If the exponent was an x, it would be exponential. All right. We got to get everything in standard form, which means we need all 3 terms on one side, and we need to put them in order from the biggest exponent to the smallest. So I'm going to subtract the 4x to get it to the left side with the rest of it. And I'm going to also put it in standard form. So first I'm going to put the x squared, then the minus 4x, and then the plus 3. All right, take a moment and let's see if this factors or not. I don't think it does. Oh, it does. Yeah, it does. All right, so you guys got -3 and -1. And that gives me x minus 3, x minus 1 equals 0. Now, the reason we factor is because if I know that the product of 2 things, x minus 3 and x minus 1 is 0, then I know that one of those things has to be 0. Because the only way 0 can be the product is if I'm multiplying by 0. So now I can set each one equal to 0 and find my solutions. Thank you. So some of you can jump to the solutions pretty quickly, and that's okay. But I like to show my steps. So to solve the first one, I add 3 to both sides. And then to solve the second one, I add 1 to both sides. All right, and then our last step is to check for extraneous solutions. Would either of these numbers, oops, you can't see them. Would either of those numbers make one of your denominators 0? So my denominator is just x, right? Looking at the problem. So if I put 3 there, my denominator is not 0. If I put 1 there, my denominator is not 0. So they both check out. Okay? So, check. Okay. X plus 2 is a denominator, and x minus 1 is a denominator. So our common denominator is going to need both of those. So my least common multiple, which is my common denominator, is x plus 2 times x minus 1. Okay. The first fraction, it has the x plus 2, but what's it missing? Yes, it's missing x minus 1. So the first fraction is going to be multiplied by x minus 1 over x minus 1. The next fraction, it has the x minus 1. What's it missing? It's missing the x plus 2. I'm going to change this minus to plus negative so I don't miss out on distributing that. All right. What about the 0? What is it missing in its denominator? It's missing everything, right? We're going to put it all there. It actually is not as messy as it seems like it might be. I'll show you how in just a sec. Yeah, it does become 0. You're right. All right, so the 0 was missing both, so I put them both there. However, what's 0 times x minus 1? 0. And then what's 0 times x plus 2?
0.
Still 0. So my numerator is going to become 0 on this side. On this side, I'm going to distribute. So what I'm going to do is I'm going to do one more step with you and then give you a minute to work. I got one fraction. Distribute, I get 3x minus 3 minus 6x minus 12. Oops, sorry. Okay, this problem actually ends up not being that bad because there's not going to be any factoring in it. All right, so looking at this, in your next step, you want to multiply both sides by the denominator so that you can cancel it out. So what we did was we multiplied both sides by x plus 2 times x minus 1. I wrote them on top of each other because I was out of room, but you know that they're actually being multiplied, not divided. Okay? So this one cancels this one cancels this one. Whoops, and these cancel. Okay? So now we're left with something much nicer. 3x minus 3 minus 6x minus 12 equals 0. And what's our next step? Combine like terms. Good. 3x minus 6x gives us what? Negative 3x. Good. I'm going to move over here. So negative 3x. Negative 3 minus 12 gives us what? It is negative 15. Good. So negative 3x minus 15 equals 0. I'm going to stop there because I think some people are still processing previous steps. All right, and then I'm going to have to get the x by itself, so I'll add the 15. And then divide by the negative 3. All right. I have not done the check step yet, but what questions do we have so far? Let me give you 30 seconds to process, and then we'll do the check step. All right, so I need to check and see if it makes any of my denominators equal 0. So to check, I'm going to put negative 5 for the x here. So negative 5 plus 2, well, that's not 0. And negative 5 minus 1, also not 0. That means that my answer checks out. So I just had to check and see if it would make the denominator 0 when I substituted it back in. Please help out when you have stuff that you can help with. All right, number 2. Quiet down, please. We're going to have Carmen explain. Okay, Carmen, what did you multiply the left one by? Good. So the left one was missing the 4 in the denominator, so multiply by 4 over 4. And how about the right one, Carmen? Carmen, what did you multiply the right one by? Good. Good. All right, so now we have a common denominator, which is good news. Sorry that you couldn't see that. Oh, so you still can't see it. But now you can. All right, here's my common denominator. For the numerator, 4 times 7, 28. And distribute. All right, so we want to get rid of our denominators. So we're going to multiply by 4 times x plus 3 on both sides of the equation. All right, so we have a much simpler equation now. Good. All right, so guys, listen, when we factor, you have to have one side equal to 0, because if one side doesn't equal 0, we can't use the zero product property. So x squared plus 3x minus 28. All right, you always need to make one side 0 before you factor. If you did not know that, please make yourself a note. Always make one side 0 before you factor. All right, and then Gideon, what did you get for your factors? That's not exactly what you wrote, though. You wrote what in here? Yeah.
X plus 7.
Uh-huh.
X minus 4.
Yeah, you're just skipping ahead on me. Okay, so x plus 7 times x plus 4 are the factors of x squared plus 3x minus 28. Because 7 and negative 4 multiply to make negative 28 and add to make 3. Now, the zero product property tells us if the product of two things is 0, one of them has to be 0. So now we can set both of your factors equal to 0. We have two solutions. We have to check both of them. So looking at your denominator, I've got an x plus 3 in the denominator, so I just need to check that they don't make my denominator 0. So negative 7 plus 3 is not 0. That's good. 4 plus 3, that's not 0, and that's good. So that means they check out. Okay, so some of you did this one first, some of you did number 3 first, and you'll be able to help us with that one. Okay, in number 3, what do we have to multiply the 7 by? X minus 2, good. So we're going to multiply it by x minus 2 over x minus 2. I can kind of fit it in there, but not quite, so I'm just going to write it again. Equals. Okay. Oops. All right, so I had to multiply the 7 times x minus 2 over x minus 2. Now I have a common denominator. I am going to distribute. Okay. So I have a common denominator, and now you multiply both sides by that common denominator to eliminate it. Okay, So I combined the negative 14 and the plus 10. What would you like to do now? Do you want to subtract the 5x or subtract the 7x? You can subtract the 5x, but and I'd like to do that because it's something that some people mess up sometimes. When in subtracting the 5x, they forget that there's two sides to the equation. Not everybody, just some people. So when you subtract the 5x, people get 2x minus 4, but then they forget that there's an equal 0 over here. All right, and then if I have 0 equals 2x minus 4, I can now add 4. And divide by 2. And I get x equals 2. Am I done? Gotta check it, right? I want to check and see if it makes my denominator 0. What happened this time? Yeah, it does make your denominator 0. So what does that mean in terms of solutions? You guys hear Blaine? I'm going to hire you, Blaine. You can teach it. Blaine says there's no solutions. She's right. So we got x equals 2, right? But then if I put it back into the denominator, 2 minus 2 equals 0. So that means it's extraneous.